I'm going to walk you through how to solve some upward launch problems, and you'll see them. That'll be a couple different ways. So I'll start off with upward launch number 1, and I'll do upward launch number 2 here in a moment. The equations we're going to work with, we're going to talk about distance in the y direction. We're simply going to say that the height in which this object was launched, right, what we'll call the d of y is going to be the height here, is 30 meters. So we can solve having just a little bit of information. Let's say we toss an object up. So the object is going to have a velocity upon being launched here at x. And we can talk about what is velocity is going to be the instant before impact here at y. It's supposed to be a y. So x and y. So remember, my velocity is going to be a positive velocity here. It's going to be a negative velocity here. Simply directional. Velocity is a vector, so direction matters. So positive velocity over here, negative velocity. So let's do some solving. So I'm going to ask you questions. I'm going to make sure you know how to process this information. So the first thing you know is what information is given. You know that the height at which the projectile traveled was 30 meters. So I'm going to ask you the time, the time in which it took to reach this highest point. So the time here, if I look at what's going on in terms of my equations, the components here, I know that I have d of y. So I have this information. I can just simply isolate t and solve. So the time for this object to be in free fall, oh yeah, we must assume that both objects are in free fall. So t is going to equal the square root of the height at which it was launched divided by 5. So here I can take the square root of 30 divided by 5, which is going to be the square root of 6. And you'll find that the time to reach this highest point right here is going to be 2.4 seconds. In other words, it took 2.4 seconds to travel up, 2.4 seconds, and it took 2.4 seconds to travel down. Therefore, your time total, right, the total time that this object was launched and came down to fall is 2 times this value. It's going to be 4.8 seconds. That object was in the air for 4.8 seconds. And then the next question, or another question I'm going to ask, is going to be, what was its velocity? What was its velocity at both x and at y? And you'll find that they're going to be equal in magnitude but opposite direction. So let's just treat this like it was in free fall. Let's treat like this object fell from this location, right, of 30 meters, and it was in free fall its entire flight down, as it was. So let's solve for this velocity at location y. So I'm going to call it velocity at location y. Is going to be g times t. Now the key here is that on Earth, we know that acceleration due to gravity is negative 10 meters per second squared. So we can solve this. With the velocity at location y here is going to be negative 10 meters per second squared times it free fell for 2.4 seconds. And you'll find that the velocity at y is going to be negative 24 meters per second. So that said, if the velocity here is equal magnitude, the velocity here in a positive direction, the velocity that's going to be at this location x, is going to be 24 meters per second, and it's going to be a positive value. That the velocity at which it was launched at here, upwards, it's going to slow down, slow down, slow down, stop, accelerate, accelerate, accelerate. Here it's decelerating on the path up. Here it's accelerating, it's speeding up downward. Downward happens to be negative. So notice g, it's very key here that we make sure we're emphasizing the negative. Negative 10 meters per second squared, negative acceleration. So another scenario I can give you, I'll call it upward launch number 2. If I tell you that the total time in the air, right, it's just a little different scenario. We will be using the same equations here. So if the time in the air total was 6.6 seconds, you should see that it took 3.3 seconds to travel up and 3.3 seconds to travel down. And as a result of this, I can ask you, well, what height did it travel to? So d of y is going to equal 5t squared, right? The height at which it travels can be 5 times 3.3 seconds. This gets squared. The height at which it traveled to is roughly 54 meters. It means it traveled to a height, right? d of y equals 54 meters. Pretty close, 54.4. We'll go 54. So when I look here, the next part is, well, what is going to be the velocity at, we'll call this location A and we'll call this location B. Remember, they will be equal in magnitude. Here it's going to be positive, here it's going to be negative. The velocity up here is going to be equal to the velocity equal magnitude. This is simply just going to be a negative value. So when I solve this, I can simply use my equation here. I know that the velocity at location B is going to be gravity times time. It free fell, right? G is negative 10 meters per second squared for 3.3 seconds. You'll find that the velocity at location B, the instant before impact here, oops, let me get you in the screen. There we go. At this location, if it free fell from this location, right, if it free fell from 54 meters, it's going to have a velocity of negative 33 meters per second. And therefore, we can make sense of this. Well, if it's equal in magnitude, the location of the velocity at location A, the velocity at location A is going to be the same velocity, only positive, 33 meters per second. Hopefully, those will help you.